Find an equation for the line containing 2, -1, which is perpendicular to the line given by 3x plus 4y equals 24. Okay, so since we're looking for something perpendicular, the first thing we need to do is put this equation in slope-intercept form so we can figure out what the slope of this line is. So 3x plus 4y equals 24. So the first thing you should do is subtract 3x from both sides. Okay, and then divide by 4. Okay, so here's our equation, and we are looking for one that's perpendicular to this. So our slope is right here, -3/4. Now remember, the slope of the perpendicular line is the negative reciprocal. So flip the fraction and give it the opposite sign. So our new slope is going to be 4/3. That's all we use from the old equation. We don't use the y-intercept or anything. So we rewrite this. Y equals 4/3x plus b. We need to find the y-intercept. So we're going to take the point and we're going to plug it in. So we're going to put -1 equals 4/3 times 2 plus b. Okay, multiply this out. So we're going to get -1 equals 8/3 plus b. Now we need to subtract 8/3 from both sides. So we're going to get -1 minus 8/3 equals b. So let's simplify this. Now -1, to put it under over 3, it's going to be -3/3 minus 8/3. That's still equal to b. So that gives us -11/3. Okay, so let's just put that in the equation. So we have 4/3x minus 11/3. So that is the perpendicular line that goes through that point. In number 5, the resistance R of a wire varies directly as the length L and inversely as the square of its diameter. Write an expression that expresses this relationship. Okay, so we have to look for some keywords. So resistance R varies directly. So this is a big clue right there. So remember, direct variation is K times some kind of value. In this case, it's L. So K times L. And then we have a second part, and it's inversely, so that's a big clue right there, as the square of its diameter. Okay, so since it's inversely, it's over, and then we have the square of the diameter, so it's d squared. So our expression is R equals K times L over d squared. Okay, so we're finished with part A. In part B, they give us some values to plug in so we can figure out what the K is. Okay, so I'm going to work at B down here. So we know that the constant, to find the constant of proportionality, we plug in 1.2 meters for the length, 0.005 meters for the diameter, and the resistance is 140 ohms. So R equals 140, K times the length, which is 1.2, and then we had the 0.005 squared. Okay, so punch all of these in the calculator. Okay, so we get 140 equals K times 48,000. So divide both sides by 48,000 to figure out the K. So that gives us K equals to 0.003. Okay, so 0.003. Okay, so let's write the equation with the k plugged in. R equals, and I'm just going to write it as 0.003 L over d squared. Now in part C, we want to find the resistance for a particular wire. So R equals, now we use this K that we just calculated, times the length of the wire is 3, and the diameter is 0.008, and that's squared. Okay, so just plug this in the calculator and figure out. Okay, so the resistance for this comes out to being 140.6. So not a huge difference. So this is a case where we definitely want to have decimals going on. So that's the answer.